dielectrics. Dielectric is nothing but a medium which is kept between the plates of capacitor or any. It is like any insulator.
Sir, is it a conducting medium or is it insulating medium, sir?
It is insulating medium. Conducting medium, if it is there, then the capacitor plates will be short circuit. How can you put a conducting medium? It has to be insulator. Although sometimes they put weakly conducting medium, but in that case also we assume as if it is a capacitor in which is connected in parallel with a resistance. We take like that in that case. If it is a weakly conducting medium, and for the weakly conducting medium, the effective diagram, equivalent diagram, we draw like this: a capacitor connected with a resistance in between. Why resistance? Because the current can flow, and if I connect a resistance in between, that resistance can also be connected here. That resistance can be connected in parallel as well. Okay, so current can flow through this side as well. Same thing only. There is no difference in these two diagrams. These right side two diagrams, and both are representing weakly conducting medium. Right. Is the spelling right for weakly? Is it right or not?
Correct, sir.
If it is week with 7 days, then it will be WW, right?
Yes, sir.
Weakly conducting medium. So in this we have dielectric of dielectric constant K. And what happens to a dielectric? Dielectric is just a, we can say it is an insulator. And if I have a, let me draw a dielectric here separately. If I have some dielectric, then one end of the dielectric will be acquiring negative charge and other end will be acquiring positive charge because of induction. Induction will be there. Now, this charge is induced if, in such a way, it will be induced only if the plate which is connected to the left side
Is positive.
is connected with positive terminal of the battery, and the capacitor plate which is towards the right is connected with negative terminal of the battery. Then only it will be like this. So this is happening because of polarization. If we look internally, what happens? So internally, I think we have discussed it before in induction only, that this material will get polarized. It will have dipoles induced, and those dipoles will be induced even if the substance is non-polar. Even then also the dielectrics will be induced. The dipoles will be induced. If it is non-polar, then also. Let us say this red color is representing positive charge. I think, wait, negative charge, sorry. The red color is representing negative charge towards the towards this side, and the green color is representing positive charge. So overall, internally, if we observe, internally positive and negatives are cancelling each other. But if we look only at the edge, then at one edge, at one end, it is all this green color, which is representing negative charge. At the other end, it is all this. I said opposite again. Green color was representing positive. Green color is representing positive, and this red is representing negative. Red one is representing negative charge here. So this is how it will be. Internally, those positive and negative will cancel each other. They will nullify each other's effect. Okay. So net charge density will be like this. And as a result, there will be field because of these charge densities. Now I can treat it like a negatively charged plate, and this I can treat like a positively charged plate. So in between, there will be field created in opposite direction. This is the field. We can say this is field induced, i.e. induced. Actual field will be initially without the
between the
dielectric. What would be the field? When there is no dielectric at all.
sigma by epsilon naught.
Sigma by epsilon, 2 epsilon.
Then it will be sigma by
2 epsilon naught.
2 epsilon
Epsilon
naught.
naught.
If there is no such dielectric in between, then you are right. It will be sigma by 2 epsilon naught. The gap which I am saying representing here, this is represented too large, but it is actually very small. You know already that. I don't have to explain every time, because the gap is very, very small and this area is very, very large. So you should understand, you should learn it, right? And this field is in positive to negative direction, this E. What will be the field in the dielectric? Guess it now. What will be the field in the dielectric? Will it not be E minus E induced, because these are in opposite direction?
Yes, sir.
But we already know that this actually happens to be equal to E divided by K, where K is the dielectric constant. What is K? K is the dielectric constant. So dielectric constant is that we can say this K value represents a number which tells us that what fraction of that net field this new field has become. So this field will become 1 by K times. This field will become 1 by K times of the old field on introducing of dielectric. This K value will always be greater than 1. For vacuum, it is equal to 1. It will be greater than equal to 1. So what will be formula for E net, E effective? E with dielectric, I can say. So I can say, what should I call this E as? Should I call it E dash? E dash. E dash. What is the value of E dash? Now E dash will be E by K, we already know. Okay. What will be the value of charge induced? Let us say, or sigma induced, I can say, charge density induced.
Sir.
Sigma induced.
Sir,
Yes.
there when E is equals to, you have written E bars, no sir, then why again it is? When there you have written E bar is equal, E net bar is equal to E bar minus E induced, no sir. Induced only you have mentioned above NASA direction. Why sir again negative?
Why again what?
Negative sir, negative. You said the
It is
direction.
in backward direction. It is in forward
We
direction.
have taken vector.
Vector sum of these two, if I have to take, then it will become this only. The net field here will be in this diagram. This diagram is equivalent to sum of these two diagrams. This diagram plus this means, in this case, dielectric is also present, and the capacitor plates are also present. When both are present, then effect of both we have to take. This is due to plates, this is due to dielectric, and this is net when both are present. Okay.
Okay.
while I'm saying this is due to dielectric, I'm not saying this is due to dielectric on its own. It is not on its own. This dielectric also must be inside the capacitor plates. Then only there will be some induced charges. If I just keep a dielectric in space, there will be no induced charges, obviously. Okay.
Okay, sir.
Right. Sigma upon epsilon naught minus sigma induced divided by epsilon naught.
Sir, 2 na sir, sigma by 2 epsilon.
No,
Total electric field in it.
total electric field inside plates is always sigma by epsilon naught. Why it should be sigma by 2? Total electric field, there are two plates here. Positively charged plate, negatively charged plate. Both send field in the same direction. Each has contribution of, oh, it is my mistake only. I understood why you are saying that. It is my mistake. I should have written 2 into sigma by 2 epsilon naught, because one has contribution of sigma by 2 epsilon naught, other has contribution of sigma by 2 epsilon naught. So total becomes 2 times sigma by 2 epsilon naught, right?
Okay, sir.
What is sigma induced here? Sigma induced we can find now. If I take it, sigma into, I think it is, wait, here also again I'm putting 2 unnecessarily. This is not 2, this is by k epsilon naught. Sigma into 1 minus 1 by k. Right or not?
Yes, sir.
This is induced charges. We are getting the induced charges here. Sigma into 1 minus 1 by k. So what will be the net field inside? E by k. When a dielectric constant k is introduced, then E by k will be the field inside. Okay?
Sir,
Yes.
sir, and A bar induced you wrote, no, sir. A bar induced you wrote, no, sir.
E bar induced, yes.
But sigma induced by K into epsilon naught, we should write, no, sir.
No. Field due to the charge distribution will always be sigma induced upon epsilon naught only.
Okay.
By Gauss law we can find out, and it will come out to be same only. Why would it be different? The laws are same only.
Yes, sir.
These laws don't depend on the medium. Similarly, if I say what is the field due to single charge Q, whether it is in a medium or it is not in a medium, it will always be Q
Q
upon
by
4
R.
pi epsilon naught R square always. Not even dielectric constant and epsilon R will also not be multiplied. This epsilon R is not should be multiplied if I have to find only field due to Q. Why we multiply epsilon R? If we don't have to find field due to Q, but if I have to find field due to sum of induced charges in the medium and the point charge Q, then we write that epsilon R here. So means whenever you see this formula somewhere written and they say that field is Q upon 4 pi epsilon naught R square, that means they are talking about it is due to just point charge Q. And when they are saying the field is Q upon 4 pi epsilon naught R square, this epsilon R is also there. Then it is the net field. It includes
Induced charges also, sir.
yes, includes the field due to induced charges of medium. Induced charges of medium. It includes those. Okay.
Yes, sir.
All right. Next we have effect of introduction of dielectric. I have to see what is the effect of introduction of dielectric in two separate cases. Case 1, when you understand the difference? What is the difference
Charge
between these?
constant, potential
Charged
difference constant,
and
sir.
charging, sir.
Not charging. It is also charged.
Charge is constant first case, sir.
Yes.
Potential
In
difference
second
is
case,
constant
voltage
in
is
second.
constant. Very nice. Very nice. In this second case, potential difference will remain constant as we are introducing the dielectric. But if I introduce in the first case, then the charge will remain constant. You have very well understood it. Very well said. Let me draw the diagrams again now below. But this time I will try to introduce the dielectric also in between. Let me make a dielectric here. Maybe I will make it like light dielectric. This is better. This is a dielectric now being introduced in this, or maybe introduced already. Similarly, I will introduce the dielectric on the other side. It is here. Single plates of the capacitor. Now, what difference will be there in these two cases? In number one, as you said already, the charge will remain constant. Q final will be also equal to Q initial only. In second case, V final will be equal to V initial only. If V final is same, then E final will also be equal to, I think rather than saying final, why don't I say E1 and E2? We can say like this here, right? Q2 will be equal to Q initial. Although it is same thing only. Let me call this as V1 and let me call it as Q1. Q1 is initial and V1 is initial. So here final is also initial and here Q2 is also equal to Q1. But now if V2 is equal to V1, what about E2? E2 is also equal to V1. Reason? If you don't understand reason, remember this formula. Because E is equal to V by D. Does the D value change?
No, sir.
Distance between plates remains same. Only dielectric is getting introduced. Therefore, field has to remain same. Come to the first one. Similarly, sigma 2 is equal to sigma 1, and you understand that very well, I think so. In first case, sigma 2 will be equal to sigma 1 only, right?
Yes, sir.
Because charge with charge per unit area will be sigma. What about potential? What about C? Capacitance C. Can you tell something about C?
KC, sir.
What happens to the field? Field, we know already that when dielectric is introduced, the field becomes E1 by K. I discussed
Yes, sir.
before only. In fact, the dielectric constant we can define in such a way. This dielectric constant tells us that what will be the fraction of field we obtain after introducing the dielectric. If I obtain 1 by 2, then the dielectric constant will be 2. So it is defined from that value of that fraction of field which we obtain. It is defined from that only. So E2 we know here. What about Q charge in the second case? Or in second case, I think Q we can write Q2 is equal to C2 V2 is equal to K into C1.
Sir, C is same. No, sir. No, sir.
Capacitance will become K times. Reason is formula for capacitance, you remember?
K epsilon naught A by D.
Epsilon T by
Epsilon naught A by D,
D.
but epsilon naught here will be epsilon in this case. So epsilon means epsilon is equal
K
to
epsilon
epsilon naught
naught.
into
K into
epsilon
epsilon
r,
naught.
which will be equal to K into epsilon naught. Epsilon r is equal to K only. So capacitance becomes K times. In this case also I can say capacitance finally will become K times of initial capacitance. That will happen in both cases. It will become K times only. Other formula are there. Energy formula. Energy U2 I will prefer to write formula half of C2 into V square. Reason is V same, so it will be easy for me to remember. Just I have to worry about C. So half of K into C1 V1 square, which is equal to K times U1. So U2 is equal to K times U1. What about U2 in first case? In this case, I will prefer formula half of Q square by C.
Q square by KC.
Because Q is easy, I know Q is same only. So I will prefer this way, Q square by C2, which will become half of Q is remaining same, but capacitance becomes K times. So what happens to U2? U2 becomes U1 by K times, because here it is K here, right? In the denominator. So here energy is becoming 1 by K times. Here energy is becoming K times. What about the volume? Volume finally and finally also same volume between the plates. Here also same volume between the plates. That volume does not change. So what happens to energy density U? Energy density U2 will also be equal to U1 by K. Here also small U2 is equal to K into U1. U is energy density. You may think what is difference between capital U and small u. I am representing for energy density. Energy density. Yes.
Energy density is half epsilon naught E square, no sir?
Energy density is half of
Epsilon naught E
epsilon
square.
naught
B
into
square.
E square.
Then U1 by K square.
E is becoming 1 by K. What about epsilon naught? Epsilon naught will become epsilon K times
Yes, sir,
epsilon
yes,
naught.
sir.
Same thing only, right?
Yes, sir.
If you do that way also, then also same, because epsilon naught will change into epsilon when the medium is introduced. It will become half epsilon E square. Okay. K times epsilon naught into E naught upon K. Write down in order to make this point further clear. Okay. Which will become again half of epsilon naught into E naught square by K. But easier way to do this will be by potential energy formula. That is easier way to approach. But this way also we can approach. But don't forget that epsilon also changes in this. Okay. Similarly, for second case, if you can find out, then it will become half of epsilon into E square, which is equal to half of. I changed this notation. Sorry. Epsilon 2. I should have written. Epsilon 1, and E1. Here also it will be 2, then it will become epsilon naught into K, epsilon 1 into K into E1 square, which will become K times, this is U2, K times U1. Okay. Is it right?
Yes, sir.
Next, any other parameter which I am forgetting? Normally we have charge done, capacitance done. Capacitance is very
Potential
easy.
difference in first case.
Capacitance is K times, or potential difference in first is remaining, right? That we can write in. There are two ways to write the potential difference. One is first you find field and
Q
then
by
multiply
C.
by D. Second is write
Q by
capacitance
C.
formula and Q by C. Yes, both ways are good enough. So if I have to write potential V2, I will prefer maybe Q2 by C. Directly it gives us Q2 by C2. Q2 remains Q1, but C2 becomes K times C1. Then it will be V1 by K. Done. This is also done. This formula we should remember. Okay. Other than that, will there be any energy lost or not? That also we can tell now. What is the energy equation in second case and what is the energy equation in first case? Work energy theorem we are applying. In first case, is there any wet battery?
No.
Yes, sir.
So there will be no work done by battery in the first case. In first case, I have to use delta U plus heat produced is equal to work done by battery. This is the formula. Fundamental formula is this. Work done by battery is equal to delta U plus heat produced. But work done by battery, nothing is there, 0. It is because isolated. Delta U. Delta U will be there or not? That we know here now. It is there. Finally, it is becoming less. It is becoming less.
Yes, sir, it is becoming less 1 by K times.
Final potential energy is less. If final is less, U2 minus U1 plus H, then what will be H? H will be equal to U1 minus U2, which will be equal to
Half C1 V1 square.
U1 by K.
U1 now 1 minus 1 by
1
K.
minus
Sir.
1
1
by
1
K.
by K, sir. Yes, sir.
U1 into 1 minus 1 by K. That is equal to heat energy produced. What about second case? Second case, work done by battery will be there now. Why? Because the charge is changing. So it has to supply extra charge. How much charge it will supply? Q charge it is supplying, and that Q is equal to final charge minus initial charge.
K minus 1
Initially
into
Then
Q and extra
Q2 minus Q1 into V remains same. So V1 I can write delta U. Delta U will be now same or different? U K times.
K times.
So U2 minus U1 and plus H. U2 is K times K minus 1 into U1 plus H. And what about Q2 minus Q1? I can write as
K into K minus 1 into Q1.
minus 1
K-
into Q. U
K minus 1 into
Q.
Q1
V
V1, right?
V- Yes.
Which I can write in terms of CV square if I want to write what it will become. Let us write in that terms also. Here also I can write finally what you are saying. You are saying half of Q1 square by C1 into 1 minus 1 by K, and there I will write K minus 1 into C1 V1 square is equal to K minus 1 into half of C1 into V1 square plus H. What is H?
So we're
Sir,
finding
half
H1 and
of K
also
minus 1 into C1 V square, sir.
Half of K
Half
minus
of
1 into
C1 V square.
C1 V square. One thing I would like to say here, and that is very important because otherwise this complete discussion will go wrong only. This heat energy which is produced, how do we know it is produced? Maybe it is not produced, maybe while it is pulled, it may start executing SHM and it may gain some kinetic energy. So there may be no heat energy produced actually. That is also possible. Is it possible or not?
That's possible.
I think I have done wrong then. I should have written here plus both sides I have to write same thing only actually. The thing which I am writing H, that should be written as kinetic energy. What will be the kinetic energy gained? Okay.
The
But
better
case-
delta cases.
Delta K, change in kinetic energy. There is a problem here. K is already used. That's why it is good idea that we should write delta K. What is delta K coming out to be? No, you tell me.
Delta K, that one also half of K minus 1 into C1.
This is only delta K.
Yes, sir.
Okay. So fine. And this K, I think I should use K. I now onwards I will be writing K as not capital K but small K only. That is better, it seems. It is creating a confusion. Okay, fine. I'm not going to change it in all the places. Now you understand that here this capital K in this question, in this last steps, here I am writing capital K as kinetic energy and the small K as dielectric constant. Now, you may ask me another question, that why did you suddenly change heat energy? Maybe it is heat energy only. Actually, what happens in the beginning when it is pulled, because it suddenly feels a lot of force here, and if the surface of the plates of the capacitor are frictionless, then it will really gain some kinetic energy, and it will not stop here because of inertia. It will go beyond that. It will go other side also. So what will happen to it? It will start executing some SHM. It will start executing SHM. What happens to the other one? It will be also SHM or oscillatory motion. We are sure. We are not sure about SHM because If I have to prove it is SHM, then I have still to do some extra work. I have to prove
A
that
square
force
is
is
equal to
proportional to minus of k times the displacement. This k again, this k is spring constant, not this k. Means force is directly proportional to minus x. Then I can say it is SHM. Otherwise, it may be just some oscillatory motion. Similarly, in second case, it may be just oscillatory motion. So we have to wait for some time to be able to prove that what kind of motion it is. But because I have already done it before, so I can tell you, if I remember it right, sometimes I forget also, but if I remember it right, then I think in second case, it is a periodic motion, but not oscillatory, because the force here comes out to be constant. And I think if I remember it right, then I think in first case, it is probably SHM, but I'm not sure about that really. I have to first find it out, then only I can tell. Okay, but oscillatory is sure, it will be oscillatory motion. And what about the heat energy produced? Heat energy will be eventually produced after a long time only, not at that time, when gradually their oscillations will finish and finally it will come to rest in between. If it finally comes to rest, then there will be heat energy produced. Sometimes what may happen? Sometimes there may be a person here who may be applying external force F. For what purpose? Either to bring it out or to let it move in. If I am letting it move in slowly, it is not getting accelerated because of external force which is opposing it. In that case, what will be the equation? Then our equation will have change in kinetic energy 0. But instead of that, I will have to use here work done by external force. Then our equation will change here. Then our equation work energy theorem will become work done by external force plus work done by battery is equal to delta U plus no change in kinetic energy. Why no change in kinetic energy? Because we are moving it slowly inside. There will be no change in kinetic energy, right? Now, how to prove that there is no heat energy produced? That I can prove in a very simple way here. That was my mistake, why I took heat energy in the beginning. That was not produced. Somebody may think, especially in the second case, that heat can be produced because the current is flowing or not in second case. Is it flowing? When the charge is flowing, there is a current or not?
Yes, sir.
Yes, sir.
What is power dissipated?
I square R.
What is resistance in this?
Resistance of conducting.
0? 0 or not?
Yes.
If it is 0, then 0 times some R is 0. So I square times 0 will be what?
0.
0.
Therefore, heat energy produced will be
0.
But here again, is it always true that I square into 0 is equal to 0? What some condition is there?
I should not be in.
Yes, very good. This boy has completely said it right only. Very nice. Very good. I should not be infinite. First of all, while I'm saying such things, I have to mention, I have to specify that I is not becoming infinite. How to tell you that I is not becoming infinite, or how can you guess that I is not becoming infinite here? Because of this reason, that while it comes inside, does it take finite time or 0 time? While this capacitor will be coming, dielectric, while the dielectric will be coming inside, it will take finite time or not?
Yes, a finite time.
Finite time. What is current? Current is equal to charge flown in finite time. So if the charge is finite and time is finite, can we get infinite value?
Nope.
That is the reason. That is the reason I is not infinite in this case. If I is not infinite, then power has to be 0. Let me take another example when power will not be 0. This is a battery. This is a switch. I am closing the switch. When I close the switch, what time does it take for the circuit to become open? Circuit to start means switch to become closed and circuit to start. What time it will take? 0 time only.
Almost 0.
Because when the moment of wire touches, at that time only the current starts flowing. 0 time. And what charge flows here in that 0 time? It becomes CV. It is V here. So potentially suddenly here the charge will become CV in 0 time. Then what will be the current in that case? Infinite. And if it is infinite current, then what happens? Then there can be power loss. Even though the resistance is 0, even though it is a conducting wire. I hope you got the point where power loss may be there. Last week there were such questions only. Remember, they were asking the power loss cases. while there was zero resistances also. So that is the reason why
Sure.
they were asking those cases, right? Understood?
Yes, wires will be having some resistance.
If what are you saying?
You are saying that heat will be produced. It will be
Heat
from
will be
wires.
produced in this case, but not in our example. So it was my mistake. I'm sorry, really, that I took H in the beginning. But remember, in this case, there will be no H, only change in kinetic energy. Work done by battery is equal to delta U plus change in kinetic energy. Here also, work done by battery is equal to delta U plus change in kinetic energy. And in this work done by battery, sometimes we may have here, depending upon the question, if the person is slowly bringing it inside, then it means he's doing some work done by some external force. Then I have to add one more term here. Work done by external force plus work done by battery is equal to delta U plus delta K. This will be our equations. Okay. In that case, when work done by external force, to bring it slowly inside, then delta K will become 0 because external force is doing work in such a way so that the person is moving the dielectric slowly inside. Okay, then delta K will be taken 0. Now let us do some questions based on this idea. Yes.
Heat will be produced when initially there will be no dielectric, and then dielectric is introduced. But put initially it is put in case 2, then we can say heat is generated. Sir.
Initially, if dielectric is already there, and there is no such switch here. If you are saying that when I made this circuit, at that time heat is produced or not, obviously heat was produced. But usually when we ask heat is produced in this process of inserting the dielectric, then obviously answer is no. Heat is not getting produced in the process of inserting the dielectric. Already when we made that, at that time it was produced. That is a different thing. If dielectric is already existing in and we suddenly make the connection, then also heat will be produced. That is also separate, a different thing. Okay.
Okay.
Right. Now, one thing I think I can mention now only before moving on to force acting on dielectric questions, which will be slightly tougher. Before force acting on dielectric, remember this I have maybe tomorrow I can take force acting on the dielectric, or today also I can try if it is possible. But before that, I am taking breakdown strength, breakdown strength of dielectric. What does breakdown strength of dielectric mean actually? Sometimes it could be breakdown voltage. Sometimes it could be breakdown charge. Sometimes it could be breakdown electric field. When nothing is mentioned, then usually they refer to it as breakdown field. It means that at what field we should have, what should be the field inside the dielectric so that the dielectric starts conducting. You know, dielectric can be conducting also. It can start conducting if the field is very high. Then what happens to dielectric? It will start conducting. So what is electric field? Which electric field will be called as a breakdown strength of the dielectric? That electric field value will be breakdown strength of the dielectric at which dielectric
becomes
starts
conducting.
It will start conducting. Okay. So normally if I have to make air also conduct, then field is very high. It is of the order of 10 raised to power, I think if I
Sigma
remember right,
induced is negligible.
6 volt per meter, or maybe 7 volt per meter. It is very high field for the conduction of air. But for other dielectrics, it may not be that much high field also. For small fields also, they may start conducting. What about voltage? Why do we call dielectric breakdown? Actually, breakdown voltage is not for dielectric. That normally we use for capacitors. And this also normally we use for capacitors. What does it mean? Breakdown voltage of capacitor or breakdown charge of the capacitor. I think you can guess. It is also when the capacitor plates will start conducting. What is the voltage at which
required charge?
Voltage required in such a way so that the capacitor starts leaking, or capacitor starts leaking means the charge from the positive terminal starts going to the negative terminal. That is the breakdown voltage of the capacitors. Similarly, breakdown charge, the charge at which the capacitor starts conducting. Now I want to make some points here. if I have multiple capacitors in series, then what will be common? What will be same thing in all of them?
Charge, sir.
Very nice. If I have all the capacitors in parallel, then what will be common in them?
Potential.
Voltage.
Potential.
Potential.
Potential. So if I have such first system of series charges, and each has breakdown voltage given as V1, V2, V3, V4. How to find the effective breakdown voltage? What is this effective breakdown voltage? Means what voltage I can safely apply so that the capacitors don't get damaged. This may be referring to leaking, or it may be referring to damaging of capacitors also. It may mean anything. So what voltage should I apply so that, what safe voltage I can apply so that the capacitors don't get damaged? That will be the breakdown voltage, effective breakdown voltage. So can you tell me what voltage I can apply now for the combination? Remember and learn it. Whenever they are giving individual breakdown voltages and connecting in series, then first you convert into breakdown charges. How to convert into breakdown charges? C1, C2, C3.
C1, V1, C2, V2.
C1, V1 is the effective breakdown charge for the first one. C2, V2 is the effective breakdown charge of the second one, and so on. So in series, I should give a charge in such a way so that any one of these capacitors should not get breakdown. What does it mean? That the value of Q, effective Q, should be minimum of
All the Qs.
Q1s, Q2, and Qn. In which case, when we have to connect in series. Then what will be the effective breakdown voltage now? Once we know effective breakdown charge, then effective breakdown voltage is very easy to get. Q divided by C effective. What is effective C? That is Q divided by
Sigma.
Q into 1 by
Sigma.
C. And what is Q here? Q is nothing but sigma. Q is minimum. Q already I told you. What is Q? Minimum of, if they have not given Q1, Q2, you have to determine what was V1, V2, V3 referring to. V1, V2, V3, etc. are
individual breakdown voltage.
Yes, individual breakdown voltages. And the charges are individual breakdown charges. Okay, this Q is the effective breakdown charge for the series combination. Similar analysis I have to do for parallel. In parallel, what is same? Voltage is same, right? But what can be different?
Charge.
Charges. Let us say they are giving breakdown charges in parallel. Then I have to first find out the breakdown voltage. If they are already giving the breakdown voltage, then effective breakdown voltage will be minimum of individual breakdown voltages V1, V2, and Vn. That is the effective breakdown voltage. Effective breakdown voltage. But if they are not giving us individual breakdown voltages, then we will determine those by which way? Q1 by C1, Q2 by C2, and Qn by Cn. What are these values referring to? Q1 by C1, Q2 by C2, and Qn by Cn. Breakdown voltages. And what is Q1, Q2, Q3? Q1, Q2, Qn, etc. are individual breakdown charges. These are individual breakdown charges. These are individual charges which the capacitors have capacity to take. After that, these can get damaged. So what is the lesson learned? When the question is of series, even if they give us breakdown voltages, we have to first think in terms of breakdown charges and then get the effective breakdown charge. On the other hand, if they give us combination in parallel, then to find out the effective breakdown voltage, I have to think in terms of voltages. If they have already given voltages, then they will be minimum of this. But if they're giving breakdown charges, then I have to convert into breakdown voltages. And then after that, I can get the minimum breakdown voltage, the effective breakdown voltage. Once I know the effective breakdown voltage, can you tell me what will be the effective breakdown charge in the second case now? Once this V is known in second case, V can C into V.
V is equals to Q by C, sir.
Q. So, C into V is equal to Q. So, it will be sigma
C
Ci into V. That will be effective
breakdown charge.
Breakdown charge for sometimes they say breakdown charge, sometimes they say safe charge which we can apply, the maximum charge which we can give to it, effective safe charge or effective breakdown charge for the combination, for parallel combination. Okay, this is how we will do such questions. Next, sometimes they can ask about mixed, neither parallel nor series, or some this way, some series and few others in parallel. How to find out what is the maximum voltage which we can apply across this? Now, in order to find the maximum voltage which we can apply across this, if they are, first of all, the question can be that there are capacitors and I have to arrange them according to my own choice. Then I will prefer to arrange them in series. Then I can apply the maximum possible voltage. But if they are already fixing the arrangement and they are then asking what's the maximum safe voltage you can apply, then solve these separately first.
Or parallelly and then series.
Find out what is the maximum safe voltage for this. After finding the maximum safe voltage for this,
Take
find out what is the
minimum
maximum
of
safe
series.
charge for this. Then what is the maximum safe charge for this? Once we know what is the maximum safe charge for this, let us say that is Q3. Safe charge for this Q2. Safe charge for this Q1. Out of these three, whatever is minimum, that will be the safe charge across the combination. Understood?
QI by 1 by CF.
I'm not giving a general formula for this, but I think you got the idea that this
Yes, sir.
effectively we have to first find out the safe charge for this. Then we have to compare the safe charges about these three, and these three are in series. So the effective safe charge will be the minimum of individual safe charges. Okay. Next, which is more interesting than all these cases which we have done so far, and that is for parallel plate, not parallel, sorry, spherical capacitors. If I have a spherical capacitors, what you are going to do then? For spherical case, this case, inner radius is A, outer radius is B, or wait, let me take this middle one is B and the outer one is C. There's a dielectric of dielectric constant K1 here, and there's a dielectric of dielectric constant K2 here. What is the maximum safe voltage which we can apply if E1 and E2 are breakdown strengths of dielectrics K1 and K2? Of that, these are dielectric constants also, and I'm assuming these are labels also. We are referring to this as K1 and we are referring to this dielectric as K2. So E1 and E2 are the breakdown strengths of the dielectrics K1 and K2. Tell me now, what will be the maximum charge which we can give, or what will be the maximum voltage we can provide? You can think in terms of charge, because even if they are asking voltage, I recommend you think in terms of charges, because they are in series. We can treat these like two capacitors connected in series, right or not?
Yes, sir. First individual charges and then
Yes.
minimum charge.
But how to find the charge? Here charge is also not given. What is given instead? The breakdown
Q.
field is given.
Q square
That
2
breakdown
epsilon naught
field.
E.
There's also one more problem here. What area you are going to take? Here there are two areas. This area or this area. Where the field will be stronger? The field will be stronger at inner area, because when area is less, field formula is Q divided by
More electric field lines.
A epsilon naught into K. That is the formula for field. And I know area is least in this place. So if it will start damaging or it will start getting breakdown, then it will start getting breakdown in which place? It will start getting breakdown at the inner side. I don't want it to get breakdown in any place. Therefore, I should look for the inner area. If I want to look for the dielectric K2, then I will look for BA 4 pi B square. If I want to look for the breakdown of dielectric K1, then I will go for which area? 4 pi A square. So tell me, what is the safe charge for first one? For the first one, safe charge can be obtained by first writing Q1 upon K1 into 4 pi A square into epsilon naught. This is equal to E1. Then Q1 will be equal to E1 into K1 into 4 pi A square into epsilon naught. Okay. So Q1 is the, we can say, breakdown charge. It is a breakdown charge, or it is a maximum possible safe charge which we can give to the capacitor. We cannot give more than that. It is a maximum safe charge. Maximum safe charge that we can provide. After that, this will become unsafe, and this capacitor will start leaking, or it will start getting breakdown. It will start getting damaged. This is Q1. Similarly, can you find out? Similarly, what will be Q2 maximum safe charge for the second case? Second case, I can say that second capacitor is formed between which and which, between B and C. For second case, this was between A and B, but A was having smaller area, therefore I took the plate area of A. Similarly, for second case, I have to take the plate area of B, which will be now written as, what should I write it? Similarly, E2 will be equal to Q2 upon K2 into 4 pi. What is it?
B square.
B square into epsilon naught.
Yes, sir.
What will be Q2? K2 E2 4 pi B square. 1 and second. So we are able to obtain safe charges. You can ask me this question, why we are obtaining safe charges? What is the reason? I told you before, always remember, for series connection, start going through charges. For parallel connection, start going through voltages. So here we know what is the safe charge. Once I know the safe charge, then what will be the effective safe charge?
Minimum of
That will be minimum of
Q1
Q1,
and Q2.
Q2. Okay. So it will be, what will be our answer? They are asking in this case, I think question, I did not mention the question. Question was,
Safe charge and safe voltage.
what maximum voltage we can, what maximum voltage can we apply?
Effective breakdown.
Can we apply from where to where? From this,
A to C.
from across point A here and point C outside, across AC.
Or can we say
What voltage we can
effective
apply?
breakdown voltage, sir?
That is breakdown voltage. We can say it is breakdown voltage also. What is the breakdown voltage or combination? We can ask in this way also. But combination could be many combinations. I can make a capacitor here. I can make a capacitor here. So what combination we are talking about? We have to specify. I want capacitance from A to C, and I want it to be the maximum safe voltage or the breakdown voltage that we can have, at which we will just start getting breakdown.
Sir,
Hmm.
here Q is equals to
Yes.
the electric field, you are taking KQ by R.
What are you saying? Say it again. Yes, you're not saying anything. You're just saying electrical. You are taking KQ by R square. What you're saying, I don't understand.
Mistake. I found my mistake.
Okay. What was the question? I don't know. No, minimum of which one? K1, E1,
correct.
K1 E1 into 4 pi S
and K2, E2,
E2
B square. That is enough because other
Yes,
terms are same only. This is equal to what here? Again, sorry. No, it doesn't make sense because we are talking about Q. I have to write in, no problem. Let us write in the same way only. Anyway, let us say they are asking the voltage. So what is the voltage? Q upon
Q by
effective C.
C effective, sir.
What is C effective?
Series.
Sigma 1 by epsilon.
4 pi epsilon. Oh, yes.
4 pi epsilon naught.
Not AB by B minus C.
No. A B square C upon. No, it is different. It is more complicated than that. It is much complicated. We do it.
3 shells.
It is much more complicated. Reason is C1 itself is 4 pi epsilon naught
Not AB by
AB
A
upon B minus A, and also unfortunately K1. And similarly C2 is also 4 pi epsilon naught into K2 into BC upon C minus B. So don't think this will be simple expression. It will not be simple. But anyway, we can get or not. We can get C. Once we know C and we know Q, we can get the same voltage which we can apply. So can you do it now?
Yes, sir.
Right. Okay. Force acting on.
Sir.
Yes. Time is over. Which class is there now?
Class is not there, sir. Practice.
If class is not there, then stay for some time. What is the problem?
Okay.
Stay for some time. How many are there students now attending?
59, sir.
66.
It is really very unfortunate. So many students already.
Sir, from starting onwards, these many only, sir.
There are less only today. Why so?
Today, sir.
They are doing what means according to their own wish. They are joining. They are not joining, and then they are thinking that we will learn this. One class you skip and you will not understand ABC also in the next class. Okay, then I'm ending it now. Anyway, right? Next time I will take post acting on the direct.
Sir, CW, sir.
CW. Okay, you can take, although make your own CW. Don't depend on this because I will give it to you.